we are going to see the what we call one case study, that is called as a implementation of neural network for the classification of MNIST dataset. Now, in order to understand this one, first of all, what is the meaning of MNIST dataset? MNIST dataset. See this one here, MNIST dataset nothing but a is a handwritten dataset. Okay, na handwritten digits. Okay, what are the different digits are there? 0, 1, 2, 3, and so on 9. There the 9 digits are there. Okay, na 10 digits are there. 0 to 9. Now, each digit is represented in the form of a one image representation. That image contains in the form of a pixel values. The pixel contains 0 value, 0 to 255 values, or 0 to 1 value. Okay, now what it may be. So according to normally the in the black and white image, there are three types of images are there. One is black and white images, and the second one is monochrome images, monochrome image, and third one is we call as a color image. Okay, na color image. A monochrome image also called as a grayscale image. In the black and white image, the values are pixel values are between the 0, either 0 or 1. 0 nothing but a white or black, or 1 nothing but vice versa. Okay, now. And here the monochrome image or grayscale image, the values are between the 0 to 255 values. Okay, now. And color image contains three types of colors are there. One is red, RGB, red, green, blue, red, green, and blue. These three colors are there. Each color contains 0 to 255. 0 to 255. Okay, now. Now, based on these three values, we can collect the one image called as a color image. Now, here this is the one type of representation of the our image. Okay, this is the example of the 5. Okay, this is one example of the 3. Okay, now. So here MNIST dataset contains 28 rows and 28 columns are there. 28 rows and 28 columns are there. Okay, now. So that means here it contains 28 rows. 28 rows. This is one row. Like that, how many rows are there? 0, 1 to 28 rows are there, and 1 to first column to 28 columns are there. So the size of the image contains 28 by 28. Okay, now. So now what happened? Total how many features are there here? How many features are there? 784 features are there. 784 features are there. That means here the first row is called as one row features, and second row called as other row features. Like that, we are having the all the features. Okay, now. Now here in this example, 0 nothing but a white, and here see this one 255 nothing but a black. The dark black is there now. The dark pixel value contains 255. Okay, that is a black value. 0 nothing but a white value, pure white value. So the values are here between the 0 to 255. So this is called as a grayscale image. Okay, now. Now our aim is we have to develop a artificial neural network model in order to predict the given input image. What the name, what the class level of the given input image. That's our aim. Okay, now. Now, so here, in order to understand this one, first of all, what is the meaning of flattening? We have to understand what is the meaning of flattening. Now, for example, this is simple image. This image contains 3 rows and 3 columns. How many rows are there? First row, second row, third row. How many columns are there? First column, second column, third column. 1, 2, 3. First row, second row, third row. Okay, now. Now, so in order to given the input to our model, first of all, you have to identify the features here. So with the help of flattening, what happened? We are converting our input image into single vector. That is called as a flattening. Now, first of all, we have to read the first row features. Okay, first row features. What are first row features? 1, 1, 0. You have to convert in a single vector. Single vector. So first of all, place the first row. Okay, then second element of the first row, and third element of the first row. We are placing in a one by one on a single vector, and then go to second layer. So first of all, place the first row, first element of the second row, second element of the first second row, third element of the first row, second row, like that. 4, 2, 1. Then you have to place the third row of the first element, second element with third row, third element with first third row. Like that, you are placing the all things. Simply the converting the given input image into single vector is called as a flattening. Now these are called these now these this vector is acting as a input to our model. Input to our model. Now that means this is a x1 feature, this is x2 feature, x3 feature, x4 feature, x5 feature, x6, x7, x8, x9. These are the 9 features of the our input to our model. Okay now. Okay. Now see this one. Now this is one image now. What is the image now? This is a 6. 6 contains how many features are there? What is the size of the image now? The size of the image contains 28 rows and 28 columns are there. Now all the inputs are converted into total how many features are there? 784 features are there now. These 784 features are converted into single vector. All the 784 features convert into single vector. So this is called as x1 feature, x2, like that. How many features are there? 700 x 784. Okay. With the help of flattening, we are converting our input image into single vector. Now each and every input and pixel value becomes your input to our neural networks, and this is your input to and corresponding output layer is there. This is our output layer and this is your input layer. What is the input for your model? Your input pixel values. How many pixel values are there? Totally 784 pixel values are there. How we can convert that 784 pixel values into input features? With the help of flattening. With the help of flattening, we are converting all the 784 pixels into input features. Okay. Now this is acting as your input values and this output is there. Now in between we are having the different types of header layers are there. Header layer 1 and header layer 2. Okay now. In the header layer 1 we can have n number of this is one header layer. We can have this is one header layer is there. Okay now. And second header layer is there. This is the second header layer. Like that, you can add n number of header layers. It's up to you. Okay now. But what happened now? Here, in the header layer 1, here for example, we are having the 128 neurons are there. In the header layer 2, we are having the 164 neurons are there. So now this is called as a fully connected network. What we call fully connected network. What happened now? What do you mean a fully connected network? So each and every neuron, each and every feature, that means 784 features are there now. That 784 features are connected to all the neurons in the header layer 1. Okay, and perform here which operation we are going to perform here in the neuron. In the neuron we are going to perform the segment operation, and then we are performing the activation function. What is sigma now? Sigma nothing but a sigma of that is summation equal to xi I equal to I value equal to between the 1 to 784 features. Okay now, and corresponding weight values. So summation of xi with xi into wi is called as a sigma value. Okay now, totally 784 features are connected to each and every neuron. After that, we are going to perform some activation function. Each activation function performed here now. So here we are performing it may be a Rayleigh activation function or tan H activation function. Maximum we are going to use the Rayleigh as an activation function. Okay now. Then after that we are going the output of these neurons going connected to next layer neurons as an input. Okay. Now so like that here also we are having the 64 neurons are there. 64 neurons. After that, what happened? Performing the header layer 1 and header layer 2, we are going to get the output layer. In the output layer, we are having we are using the activation function as a softmax as a activation function. Softmax as a activation function. What is the formula for softmax activation function? E power x by sigma of e power x. Okay now. Now, so probability of what the input probability of based on probability value of softmax activation function, we find out the corresponding class label. Okay now. So So like that we are going to perform the things. So this is the input value and this is the output value, output layer, and in between the n number of hidden layers are there. Each hidden layer contains n number of neurons are there. So this is the like that you are going to generate the your model. Okay. Now in order to perform these things, okay, in the manually, you have to follow different procedures is there. First of all, you have to understand the business problem. Okay, what is the business problem here? Classification of MNIST data set, MNIST handwritten digits using the artificial neural network. That is your case study. Now, first of all, you have to understand the problem. That means here our problem is we are giving the input as a handwritten digit, it is a 5 or 6 or what it may be. We are printing the corresponding class label. That is our problem statement. And in order to perform this one, we require some library files are required. Okay, and then you have to read the data set. Read the data set means here the data set is maybe a MNIST data set, and then data splitting into training part and testing part. That means the MNIST dataset contains 70,000 handwritten digits are there. 70,000 handwritten digits are there. Out of 70,000 handwritten digits, okay, that means here it contains 784 features are there. Totally, we are having the 70,000 handwritten digits are there, and it contains 784 features are there. Corresponding class labels are there. Class labels. Okay, y cap is there or y is there. Okay, y. And out of 70,000 images, okay, we are dividing. We are giving the for model. We are giving the for model 1 to 60,000 images for the training purpose, and the remaining 10,000 given for the testing purpose. Okay, now. So this is called as a x underscore training value and y underscore train value, and this is called as a x underscore test value, and this is called as a y underscore test value. So like that the 70,000 images are converted into training part and testing part. Okay, now. So now each training part contains corresponding features are there and corresponding class labels are there, and testing also contains x testing features are there, and y test values are there. That is called as a splitting the data into training and testing. Then you have to perform the data pre-processing. What is the meaning of data pre-processing? If any missing values are there, then at that time you have to replace with the missing value to maximum value or minimum value or average value, or converting the 255 value 0 to 255 value into between the 0 to 1 values. Okay, this is one type of thing is called as a data pre-processing. And then before converting the after performing the pre-processing, then we are going to convert the next step is called as a flattening. What do you mean of flattening? Flattening is nothing but a converting all the 28 by 28 pixel values into single vector. Okay, into single vector is called as a flattening. All the 784 features into single vector is called as a data flattening. Then building the model. So that means building the model nothing but here based on your input features, based on we know the corresponding class labels. This is the output value, y cap value, and this is your input value, input features. And here we are going to define the how many hidden layers are there and how many neurons are there in the corresponding hidden layers. Like that, we are going to define the things is called as a model building. Then model compilation. After model compilation, model building, we have to train the model itself of compilation. Okay, now that means if any loss is there, we are going to update your weight values with respect to our optimizers and the loss functions. Okay, we'll see the code. And then model training, and then model evaluation, and then model prediction. These are the different steps you have to follow in order to develop your model. Okay, now. So now we are going to see our code in the Colab. Okay, now. What are different steps are there? Understand the business problem, import the library files, read the data set, and data splitting into training part and testing part, data pre-processing, data flattening, model building, model compilation, model training, model evaluation, and model prediction. They are the 10 or 11 steps you have to follow in order to develop any artificial neural networks program. Okay, now